Hey kids, we're going to solve some quadratic equations. It's very early in the morning, and by now most of you probably heard what happened to my little kitty, and I really miss her, but the big kitty is craving attention and clearly feeling sad, so she woke me up to play, and I guess I'll make a video nice and early here in the morning. So we're going to solve quadratic equations, and we're going to do it in 3 different ways. And first of all, good joke. What do baby parabolas drink? Quadratic formula, which is something we're going to learn soon to use to solve quadratic equations. But we're going to learn 3 methods in this video. Graphing, using square roots, and factoring. We'll come back to other methods in a later video. First of all, what's a quadratic equation? Well, we saw a quadratic function was where we have the ax squared plus bx plus c equals y, or equals f of x. In a quadratic equation, the other side of the equation is a 0. And even if the number isn't a 0, you can always subtract or add it so that it becomes a 0, and that just changes the value of the constant c. And remember, a can't equal 0 here, because otherwise there wouldn't be an x squared in the equation. And it's called the standard form of a quadratic equation. So that's what we're going to be solving now. We've graphed the functions, now we're going to solve the equations. Of course, one way to solve the equations is by graphing. So one way you do it is to graph the related quadratic function. So that would be replacing the 0 with a y, like we just talked about a minute ago, and graphing it. The solutions of the equation are the x-intercepts of this related function. Let's examine why that is. Okay, let's talk about why that is. Well, those are the points. If they're x-intercepts, they are the points where y equals 0, where x is some number and y equals 0. Well, if y is equal to 0 when we're graphing this, that's the same as this. So that's why the points that are on the x-axis are the solutions of the equation. So if you can read right what those ordered pairs are when you graph it, then you're good. So in this case, they graphed x squared minus 4 equals 0, or they graphed y equals x squared minus 4, and they graphed the parabola, and they can see that it crosses the x-axis at -2 and +2. This is a really great use for your TI-84 plus graphing calculator, because that's going to be something where you can just see the graph right off. But remember, this is only really going to work if you can see those x-intercepts. So let's look at a couple examples. So we got x squared minus 1 equals 0. Oh, excuse me, big yawn. We're graphing y equals x squared minus 1, and here's the graph of the parabola. So that means that the solutions of the equation are the same as the x-intercepts of the parabola, and the x-intercepts of the parabola are -1 and +1. And when we express solutions to a quadratic equation, we should write it like so, in curly braces, showing the 2 solutions. Okay, sometimes only one solution, like in the example of this one. The only x-intercept on this one is 0, x squared equals 0, and that should make sense, because the only number that's going to make x squared equals 0 true would be 0. Okay, it's called a double root when the graph bounces off of the x-axis like that, so it actually kind of counts twice, but we'll see that later on with a different example, with a different number. And then you have this one, x squared plus 1 equals 0. When we graph y equals x squared plus 1, it doesn't have any x-intercepts. That means that this equation has no real solution. And it's important you add the word real in there because it does have a solution. It's just in the imaginary number system, in the complex number system, which you learn about in Algebra 2. And if you want to learn more about the complex number system, that's fine. Just please don't confuse it with what we're learning this year. You can look on Khan Academy, awesome videos for what the value of little I happens to be. And you'll see that if you want to look. But, you know, again, you can pretend it doesn't exist until you get to time where you do need it. All right, so that's solving by graphing. Let's look at solving by finding square roots. Now, sometimes it's possible to find a square root. This is possible when there's no linear term. So real quick before I look at this example with you, ax squared plus bx plus c equals 0, right? This is where b equals 0. That's when this method will work the best, or will work at all. You don't have to worry about that linear term. You can isolate the x squared. Let's look at this example. What are the solutions of 3x squared minus 75 equals 0? Well, we write our original equation down. We're going to isolate the x squared. So we're going to add 75, and that's what was done right here. Plus 75, plus 75. 3x squared equals 75, then they divided by 3, divided by 3. X squared equals 25. Now this is the part that's new. When you take the square root of 25, you have to put this symbol in front of it, and it's called plus or minus. That's the name of the symbol. And what it indicates is that there's actually two answers there, both a positive and a negative 5. Because if you take the square root of 25, it could be a positive 5 squared to give you 25, but it also could be a negative 5 squared to give you 25. So the rule you're going to follow is if you put in this radical sign like we do right here, square root of x squared, square root of 25, you have to put in a plus or minus. So if you are solving an equation and you have to use a radical sign to solve it, you have to put a plus or minus in front of the result. Let's look at a couple examples. Oh, sorry, big yawn, very sleepy. Okay, so for this first one, m squared minus 36 equals 0. So let's add 36 to each side, leaving me m squared equals 36. Now, square root, m equals plus or minus 6. Because it could be positive 6 or negative 6, just like we discussed. And that's it. That's it. All right, how about this one? Subtract the 15 from each side. Subtract 15. We get 3x squared equals negative 15. Well, let's keep going anyway, just for kicks and giggles. Something's definitely wrong. Because when we try to take the square root here, can't do that. Can't do that. So, instead, what we're going to have to say is that, again, this is an equation that has, what do you think? No real solution. Make sure you put that word real in there. That's important that we recognize that for later. Okay, how about the last one? 4d plus 16 equals 16. We're going to subtract 16 from each side. 4d squared equals 0. Well, clearly I don't need to worry too much about this one. We divide by 4, we just are going to get 0 again. And the square root of 0 is indeed 0. Now I don't need a plus or minus on that one because 0 is not positive or negative. It's in between. So this is one of those double root ones where there's only the one solution. And again, we'll see more with that with the graphs later on. All right, so that's taking square roots. And remember, that's only going to work if b is definitively equal to 0. And the last way we're going to solve is by factoring. But first we're going to talk about a new property. It's called the zero product property. I know you're thinking, oh, great, a new property. Everybody just loves properties. Well, I mean, they're rules. That's all they really are, is rules. And this one is new. This one is something, it's simple and easy to understand, like all properties really are. But it is something new. For any real numbers a and b, if ab equals 0, a times b, that is totally my alarm that says it's time to get up. That's how early it is, guys. Anyway, if AB equals 0, and I've got some really weird iTunes radio that just came on. Hold on. Phew, fix that. Okay. Here's the third try here. For any real number AB, if A and B, if AB equals 0, so that's A times B, then A equals 0, or B equals 0, or both, really. So if you have a factored form of a quadratic equation, you can take each of those individual factors. Remember, each of these sets of parentheses is a factor because it's two things that are being multiplied, right? Take each of these and set them equal to 0 and solve. And you've got your solutions to the quadratic equation. So let's look at this one right here. So what you're going to do is you're going to have it factored, or you're going to factor it. And I know that means more factoring. I know everyone's thrilled. You're going to take each one and you're going to make little mini equations. Because if the product of these two parentheses is 0, then I can set them equal to 0 individually. And then we're going to solve the little equation that we get. So 4t equals negative 1, divided by 4, equal sign got a little messy there. T equals negative 1/4. Okay, on this one we're going to add 2, that one's a little faster. T equals 2. All right, so t equals negative 1/4 and 2. And again, curly braces. Putting them in numerical order preferably, because that's the best way to do it. Okay. Notice it's curly braces and not an ordered pair, no parentheses. It's not an ordered pair. We don't want people to think it's an ordered pair. It's two values that make the equation true. Now just going back for a second, why does a quadratic equation have two solutions? Because it's a second power equation. Generally, as a rule, you can go to whatever the degree of the equation is, and that's going to be the general number of solutions. Sometimes it's the same number twice, though, but that's how you're going to be able to solve these quadratic equations. All right, let's try a couple of these. Okay, what are the solutions of the equation x squared plus 8x plus 15 equals 0? Now, I can take each of these not ordered pairs, look on, they are not ordered pairs, each of these individual solutions and plug them in until I find the right answer. We can always do that. But what would be best for us to do here would be to factor and solve like we just learned, because it's more efficient and I won't have to worry about making a careless mistake. Factors of 15 that add up to 8 would be positive 5 and positive 3. Setting each of those equal to 0, x plus 5 equals 0, so x equals the opposite of 5, which is negative 5. And x plus 3 equals 0. So again, x equals the opposite, in this case, negative 3. So we want the negative 5 and negative 3 one, which is a. I guess I should bubble it like that. There you go. All right, let's try these. So we factor m squared minus 5m minus 14. So factors of negative 14 that add up to negative 5. That would be negative 7 and positive 2. So then we have our mini equations. M minus 7 equals 0 and m plus 2 equals 0. We're going to add 7 to each side on this one. So m is 7. Subtract 2 from each side on this one. So m is negative 2. And that means m is equal to negative 2 and 7. So m can be either one. All right, next one. Let's switch colors. We haven't done that this whole video. Purple. All right, factors of negative 20 that add up to positive 1. Factors of negative 20 that add up to positive 1 are going to be negative 5 and positive 4. So we can see why factoring is an essential skill, because we couldn't solve these equations without knowing how to factor. So we're going to add 5 to each side. And there you go. And on this one, we're going to subtract 4 from each side. There we go. And our solutions are negative 4 and 5. And the third one's a little tougher. Now, before I go into the third one, real quick, let's just look at why can't I use that square roots method? Well, look, 2a squared minus 15a plus 18 equals 0. If I'm going to try to use that square root method, and I try to isolate the a squared, I'm going to get this. I'm going to get a squared equals 15a minus 18 all over 2. Now, how exactly would you take the square root of that, do you think? What you can't do is take the square root of each individual part, because that's not how square roots work. It's not equal. If you'd have to put a big square root sign over the whole thing, and you'd have to know what a is in order to be able to do that. And finding a is the whole goal of what you're doing, so that's why I cannot use my square roots method here. All right, so let's factor this last one, which is going to take a little bit more doing. We need factors of 36 that add up to negative 15. Well, I mean, of course I'm this fast. I see it already, negative 12 and negative 3. Of course I'm this fast because I do this for a living and all that. But of course, yeah, that would be what we're doing. Yeah, yep. All right, so I'm going to zoom in. Sorry for the shaky camera work there, just because I kind of ran out of space. All right, so 2a squared minus 12a minus 3a plus 18. This is our factor by grouping method. All right, I'm going to keep my equals 0 to remind me what I'm doing. So I found my factors of AC that add up to B, I broke up my middle term, and I'm factoring by grouping. So I take a 2a out of 2a squared minus 12a, leaving a minus 6. And I know this is a minus 6, and that I notice that the signs switch there, so I'm factoring out a negative 3. Almost done with this part. 2a minus 3 is one factor, a minus 6 is the other. And now I'll go that next step of setting it equal to 0. And solving. So 2a equals 3 when I add 3 to each side. A equals 3 halves. Now be careful to write this. Very easy to invert that. I know I kind of rushed through and I shouldn't do that. But be sure to write what you're doing, each step individually, so you can see it. add 6 for the other one, so a equals 6. So the two solutions are 3/2 and comma, thank you, 6. All right, and that was supposed to be a comma, it just got kind of jacked up. Now what can I do before I would quit on a problem like this? Well, I would probably go back and plug in the solutions, and we're going to do that now. That is another great application for your TI-84 Plus calculator, because you remember that you can put the value right in parentheses and just type the entire expression, and that would be a good idea, and we will do that with some of the ones that we go over in class. All right, last slide in this video coming up is a vocab slide. I know you're thinking, what, at the end of a video? Well, I just want to sum some stuff up. All right, factors, solutions, zeros, and roots. So the factors of a quadratic expression are the binomials that you get when you factor that quadratic expression. Okay, and example I could give you here, let's use the example x squared plus 3x plus 2. We'll keep it simple. That's a quadratic expression. If I factor it, I get its factors. Oh, big kitty is whining for my attention. You're going to have to wait a minute, I'm not done with my video. When I factor this, factors of 2 that add up to 3 are 2 and 1. So these are the factors of our quadratic expression right here. Okay? But we can also set our factors equal to 0, and we get the roots or solutions of the related quadratic equation. So that would be if I was to take this expression up here and make it set equal to 0. So x squared plus 3x plus 2 equals 0. Now it's a quadratic equation. It's a quadratic equation instead of just an expression when it didn't have an equal sign. And when I solve these, I get my solutions. So -2 and -1. Okay, so those are the solutions to the related equation. Finally, those solutions are also the zeros or x-intercepts of the related quadratic function. So this would now be if I was to take the x squared plus 3x plus 2 and make it y equals, or f of x equals x squared plus 3x plus 2. And if I was to graph it, this parabola would pass through, pretend that's -2 and that's -1, -2 and -1, and that would be the x-intercepts, okay, of the related quadratic function. So there's lots of different stuff going on here and a lot of different vocabulary words. This is a good set of 3 sentences to write down and focus on making sure you understand the use of each of the terms therein. All right, guys? All right. I will see y'all in class.